Slide visible, sir.
Okay. So today's talk is on the logistic regression. This is a kind of regression, but the use of logistic regression is different than the conventional regression analysis. And I think yesterday, ma'am will dictate many things regarding the regression, and now you are able to understand the what is the role of regression in the statistical analysis. Okay, so in regression, 1 second, 1 minute. In regression, we can assess the impact of the independent variable on the dependent variable. So this is a little bit different than the correlation. Correlation, we can assess the relationship between two variables. But in regression, we have additional things, that is the impact of a particular variable on the another variable. Okay, if there are two variables, there are two regression lines to know the impact of one variable on another variable. One more thing is very important to know, the causality of the variable. Which variable is regulating another variable or not? It is very important to know. So for that purpose, there are a big lecture. There may be a big lecture on the causality. How to test the causality? Suppose there is a two example. One is CBR or TFR, total fertility rate, and another is mortality, infant mortality. So the question is which variable, infant mortality regulates TFR, total fertility rate, or total fertility regulate IMR, infant mortality. So when we use some advanced technique, how to know which variable is cause and which variable is regulatory function, then we should use some advanced technique like causality test, and we need for that longitudinal data. Okay, so that is another aspect of regression analysis. So apart from the regression analysis, there is another method of regression that is known as what? Why my slide is not moving? Okay, it is moving. So simple linear regression. Okay, we have learned about simple linear regression. This table shows that age and systolic blood pressure among 33 adult women. Okay, in the first column, age is given, and systolic blood pressure is given. Is it clear? So as far as concerned to know what is the impact of age on systolic blood pressure, we can use simple linear regression. We cannot think about this systolic blood pressure. There is an impact of systolic blood pressure on the age. Age is a regulatory function. No? Age regulates the systolic blood pressure or diastolic blood pressure or any medical parameter, biochemical parameter. Okay, but the biochemical parameters are not regulating the age. So there is a causation. The direction of relation is clear. But when direction of relationship is not clear, then we need to assess. We need to analyze which direction is important. There, for that purpose, the causality test is available. So this is the scatter plot, and this scatter plot shows that there is a positive relation, because this type of a pattern is like this with a positive angle. So we can say as age is increasing, systolic blood pressure is also increasing. So this is the linear line. SPP is equal to this much. With the help of that particular data, which is shown in the previous slide, we have computed it. So how to compute this regression line, you have learned yesterday. Simple linear relation between two continuous variables. SBP, systolic blood pressure is also continuous variable, age is also continuous variable, and this is the graph, and this is the equation, simple linear regression, y is equal to alpha plus beta 1 x1. X1 is what? Variable. Actually, this is I and beta I. Okay, alpha is the slope. Alpha is the slope. When this beta 1 is 0, okay, y becomes what? Alpha. So this alpha can be interpreted as slope or starting value, or you can say this is a value that is available, that must available instead of this particular coefficient is equal to 0. So regression coefficient beta I, measure of association between y and x. This is line for y on x. When we have x and y, this become x, this y become x, and this x become y. This beta 1 and alpha 1 in that case will be different. Amount of which y changes on an average when x changes by the unity. So this second line is the interpretation of beta coefficients. So what is beta coefficient? Suppose in a model beta coefficient is 0.54. Then what is the meaning of that? If we change unit change in x, then we will get a change in y is equal to 0.54. Is it clear or not? Suppose it is 7.2, then if you change x by one unit, you will get a change is equal to 7.5. This parameter can be estimated with the least square method also. So multiple linear regression means there are more than one independent variable. So relation between continuous variable of a set of independent variable, I variables, I continuous variable, partial regression coefficient beta I. These are the what? Partial correlation. Okay, amount of which y changes on an average when xi changes by unity and all the xi's remain constant. If you want to know the impact of this, change it by 1 unit, you'll get change in y is equal to beta 1. Keeping this are the constant. Measure of association between xi and y adjusted for all xi's. The examples we can get: SBP, systolic blood pressure versus age, weight, and height. If we consider age, weight, and height as an independent variable, we will get what is the impact of weight and height. You know, this is a very simple, very popular problem. Every doctor says that for a higher age person or age person, please keep down your weight, because they don't decrease the height. So say every doctor says that, okay, if you want to control the blood pressure, please reduce your weight. So this regression, this is the beauty of regression coefficient. We want to know what is the impact of independent variable on the dependent variable. Okay, multiple linear regression, y is dependent. These are the different name of y: dependent, predicted, response variable, outcome variable. And these xi's are known as independent variables, predictor variables, explanatory variables, and covariables. So different name people's using. Multivariate analysis. These are the various regression techniques apart from the linear regression. Linear regression requires continuous data. Poisson regression, this is a kind of linear regression where the dependent variable follows Poisson distribution. So Poisson distribution is made for the discrete data, or you can say this for the count data. So if we know, or it is clear that dependent variable is a Poisson variable, Poisson variate, then we can use Poisson regression instead of linear regression. And this Poisson regression provides better result. Why? In linear regression, our assumption is that the dependent variable and independent variable are linearly related. But when your dependent variable follows Poisson distribution, then it is not linear. This is non-linear. So that instead of linear regression, we can use Poisson regression. Cox proportional model, this is used for the survival data. Survival data must be continuous. There are some another concept we use, censoring concept, and the data preparation is a little bit different than the linear regression and Poisson regression. Today's talks on the logistic regression, and this logistic regression is required a binomial outcome, or you can say dichotomous outcomes. So the dependent variable should be only of two categories, either yes or no. There are no another category. If the dependent variable is not continuous, if the dependent variable is ordinal, they can follow the Poisson regression, Poisson distribution, and in that case we can use Poisson regression. But when dependent variable is a kind of dichotomous data means there are only two categories, then we must use logistic regression. Okay, is it clear? So one second. Okay. So problem with binary outcome. When the outcome variable or dependent variable or predicted variable is dichotomous or having only two categories, we cannot use conventional regression analysis. So in a multivariate linear model, this is the multivariate linear model. Okay, and these are the various coefficients I have discussed. If outcome variable is binary nature, the example is occurrence or non-occurrence of a disease, success or failure in an examination. The dependent variable follows binomial distribution. Actually, not binomial distribution, but we assume this follow the Bernoulli distribution. But there are n observations, so we can assume that this is the binomial distribution. An assumption of the normality is violated. However, in the linear regression, the assumption of normality is valid. But here, the normality assumption is violated, so that we cannot use simple regression analysis. So in this situation, usual method of multiple regression fails to explain the relationship between outcomes and possible predictors, and we cannot estimate the dependent variable. So it is very essential to know another kind of regression. In such cases, we try to predict whether an event will or not occur and identify variable useful for making such prediction. So what are the various assumptions in logistic regression? So logistic regression does not make any assumption of normality. So it is good. Many phenomena are not following normal distribution or normality, so that this particular logistic regression provides us some facility to analyze the data. So this is also not following linearity and homogeneity of the variance for the independent variable. Because it does not impose these requirements, it is preferred to discriminant analysis. So we have an old technique that is known as discriminant analysis. We can use when normality, linearity, and homogeneity are not present, we can use discriminant analysis. Another assumptions, if the distributional assumptions are not met, discriminant analysis may be more powerful, although it has been shown to overestimate the association between the discrete predictors. There is a problem. The host of Someone asked in the chat. No. So in the discriminant analysis, the requirement of observation or sample size should be more. This is very complicated procedure. The interpretation is not much good. It is very complicated. So that we need some more advanced techniques. If the outcome is continuous, then multiple regression is more powerful, given that the assumptions are not met. If this is not, we need some another methods. So ratio of cases of variable using discrete variable requires that there are enough response in every given category. If this is not present, suppose in a category very few observations are there, we cannot use logistic regression. Suppose we have 1000 observation, 1000 individuals observation, and only 3 or 4 says S and rest no. Only 3 or 4 says no and rest all S. Then this logistic regression doesn't provide a good estimate or does not solve your purpose. If there are too many cells with no response, parameter estimate and a standard error will be likely blow up. It is too much, so you cannot analyze. Suppose I am saying that 1000 time is more in that category. People can believe. No. Everybody is saying that go through the sample size and scrutinize your data. Also can make group perfectly separable. For example, multicollinearity, which will make maximum likelihood estimate impossible. We should be very careful for the multicollinearity. I repeat, the multicollinearity, you should think about the variable first and then about the data, then about the response of that particular variable. Suppose there are 2 things, age at marriage and age at first birth. Both ages of the individual mother. Okay. Sometimes it may be multicollinear. The responses everywhere for every woman, the gap is equal to 2 or 2.2 or 1.98. Then we have multicollinearity. But both the things are different. Age at first birth, sometimes we need to know the impact of age at birth, and sometimes we need to know the impact of age at marriage. So it is on ourselves or the researcher which variable they have taken. But simultaneously, software will drop one variable. I had discussed yesterday. Suppose there is a variable age and weight. Age is 40 years, weight is 40 kg. Similarly, the same observation, by chance, the observation, the response given is numeric response is same. Then software says that there is a multicollinearity, but the both variable is different. The unit of variable is different. So it is up to you whether you have to use that variable or not. So don't blindly support the output of software. Linearity is in the logic. The regression equation should have a linear relationship with the logit form of the dependent variable. This dv is the dependent variable. There is no assumption about the predictor being linearly related to each other or not. In the conventional regression, this linearity concept or assumption prevails. But here, there is no need to follow that. Absence of multicollinearity, no outlier. If the outlier present in the data, your result may be different than the reality. Independence of error, assume a between subject design. So I think it is not for you, I think non-statistician. So sample size requirement, the minimum number of cases per independent variable is 10. Suppose you have 10 independent variable. This is a crude idea. Suppose you have 10 independent variables, the sample size should be more than 100. For preferred case to variable ratio, we will use 20 to 1 for hierarchical logistic regression and 50:1 for the stepwise logistic regression. So sample size should be adequate, but it is less than the demand of discriminant analysis. That is why this logistic regression is more useful than the old technique discriminant analysis. But the purpose of both analysis is same. So this sometimes some people say that this logistic regression is the today's fashion, and everybody using this logistic regression by imposing a boundary for the data set. Fix a particular value, and left side values are 0 and right side value is 0, where dependent variable becomes dichotomous, and people are using logistic regression. But this fashion is not good, because you are losing informations. This is the example of age and coronary heart disease of 100 subjects. We are not showing full data in a slide. So CHD means coronary heart disease. S means present. This is the response is 1. No, 0 means no CHD is there. This is age of the patient. Sorry, AGR. Age group. Okay, age group, and age is given. So as far as we want to know the impact of a particular group, we can use, or if you want to know the age as a continuous variable, we can use. So we'll discuss later on what is the importance of this continuous variable in the logistic regression, and what is the another dichotomous or dummy variables. So these are the various group frequency between distribution for the CHD. For the given data set, these are the different observation. So 10 people's age is between 20 to 29, 15 in between this, and coronary disease is there. What is the prevalence of coronary heart disease in the different age group? So as the age is increasing, you can see the prevalence is also increasing, the proportion present. Okay. In the lower age group, the prevalence is 0.1, and however in the higher group, it is 0.83. Our objective to find out the best fit and most parsimonious and yet responsible model to describe the relationship between outcome variable, which is binary in nature, and the set of predictors independent variable. Thus, the linear model is this, but P, probability of an event, lies between 0 and 1. P, this P lies between, this is the probability. So, you know, the probability lies between 0 and 1, whereas right-hand side, this of the above equation can take any value from -infinity to infinity. Then we need to transform this. Hence, equation is imbalance and the model is inappropriate. So, logistic regression model, let P is the probability of an event and 1 minus P is the probability of no event, no occurrence of the event. So, logit P is equal to this. This is ln. Ln is what? Natural logarithmic. Probability of event divided by probability of no event. So that this can be written as logit P is equal to ln P upon 1 minus P. Now, beta 0 plus beta 1 x1 and all this can be equated to logit P. So in place of P, we use logit ln P upon 1 minus P, and then this ln P upon 1 minus P becomes P is in support of -infinity to infinity. Logistic regression model, P upon 1 minus P becomes e to the power z, or P is equal to 1 minus P to the power z. P is equal to e to the power z minus, this is the decomposition of this. So from here, a simple transformation, after a simple transformation, we have P is equal to 1 upon 1 plus e to the power minus z. So probability of an event, P is what? Probability of occurrence of the event is equal to what? This z is equal to that right hand side function, where beta 1, beta 2, beta k are the coefficient of predictors. Coefficient of predictors. And E is the constant. E is the constant. The base, the natural base is this. So this particular part is what? This is what? For any value of beta 1, beta 2, this is what? This is the probability. So estimation of regression coefficient. In regression, we use ordinary least square for estimation of the coefficient. In OLS, minimize the sum of squared distance of the data point to the regression line. But in logistic regression, maximum likelihood estimate is used to calculate the logit coefficient. Manually, it is not possible. Only you can do with the software. MLE seeks the maximum of log likelihood, that is sometimes written as LL, which refers how likely it is that the observed value of the dependent may be predicted from the observed value of the independents. Interpretation of logistic regression coefficient. If BI, B1, B2, B3, BI means beta 1, is greater than 0, means there is a positive association. More likely to have event with increasing level of covariate. If the covariate is increasing, you have more likely to have the dependent variable, the occurrence of the dependent variable. If beta is equal to 0, no association between events and covariates. If beta is less than 0, negative association, less likely to have event with increasing level of covariates. So interpretation of beta. Interpretation of beta. This is a very simple 2 by 2 tables. Disease is Y, that is present and no, not present. Exposure. Let this is the corona disease, COVID-19, present, not present. Exposure, who have exposed, who are exposed with the society and getting an infection. S, no. So this is what? This is the conditional probability of Y given X is equal to 1. This is what? Probability of Y given X is equal to 0. This is 1 minus probability of Y given X is equal to 1. 1 minus probability of Y given X is equal to 0. So P upon 1 minus P is equal to e to the power alpha plus beta X. So this odds of disease and exposed, e to the power a plus b. Odds, disease, not exposed. When a beta is absent there. So e to the power alpha only. So odd ratio is equal to this divided by this. This is the presence and this is the absence of the disease. So finally this becomes e to the power beta. E to the power beta. This is in the probability form. So we need e to the power beta instead of beta. So taking ln, natural log, both sides, this becomes beta and this is ln of OR. So natural log of odd ratio is what? Simple beta. So every software provides beta and e to the power beta. So the explanation of beta is more powerful because this odds ratio is this p by 1 minus p. Means this is the ratio of occurrence of the disease and not occurrence of the absence of disease. So now consider a dichotomous predictor. Again, I'd like to show with a different example. This table is different. This is the risk factor and this is the disease. Means people is exposed. Everything is same in the previous slide, but this is different. The odds ratio is what? Odds of disease with risk present, odds for disease with risk absent. So this is the ratio. which is given in the previous slide. So e to the power beta 1, and this has the explanation. This is what? This is the probability. So suppose the value of e to the power beta is 1.2, means we'll discuss later on. So 1.2 is a comparative value with what? With 1, so that we can interpret the result in terms of probability. We'll later on discuss about what is the interpretation, actual interpretation of this. Interpretation of beta increase in log odd for 1 unit increase in x. Same explanation is there. What in the linear regression? In linear regression, if we increase x by unity, we will get a change in y is equal to beta. Here, same, but e to the power beta is in terms of probability. The interpretation of e to the power beta is different than beta. So test of hypothesis that beta is equal to 0. This is also known as the wall test. Chi square is equal to beta square upon variance of beta. So we need variance of beta also. If we have, we can test this. And this is the interval testing. 95% confidence interval is equal to e to the power beta plus minus 1.96 SE of beta. So these all are directly computed. This software compute this. Software provide, after running this logistic regression, you will get a output, and there is a need to explain what is the meaning of that. So example is 55 less than and 55 plus years, and the risk of coronary heart disease. So this is a dichotomous disease present, absent, age is given. So 21 people whose age is more than 55 having coronary disease, and 22 persons age less than 55 have coronary disease. Coronary disease is absent for the 6 people whose age is more than 55, and for 51 people are there who don't have the coronary disease whose age is less than 55. So odds of disease among exposed is what? Who is exposed? Among exposed is 21/6, and odds of disease among unexposed is this. So odds ratio is what? The ratio of these two. The ratio of these two is 8.6. 8.1 means 8.1 means in comparison of the people whose age is less than 55, the coronary heart disease is 8 times more in the person whose age is more than 55. So result of fitting logistic regression is this: log of p upon 1 minus p. This is the beta. Alpha plus beta 1 into age, you'll get this. Okay, for a particular age people, you'll get this beta coefficient or risk. Generally we don't use a particular age for a particular age. People are using group of peoples. So coefficient age is this, and standard error. This is the out. Log out is this. OR is equal to this. Wall test 3.96 square with 1 degree of freedom. This is the equation which I have discussed, 95% confidence interval. This is equal to this. Okay. So using this 2.9 and 22.9, we can decide whether the variable is significant or not significant. Multiple logistic regression. In logistic regression, we can use one variable, and in multiple logistic regression, we can use more than one variable. Okay, more than one independent variable: dichotomous, ordinal, nominal, and continuous. Okay, one more thing is important. I have left this. The dependent variable for logistic regression is logistic regression must be dichotomous. However, the independent variable may be dichotomous, may not be. It should be ordinal. It should be, it may be, not should be, may be nominal, may be continuous. But it is mandatory that dependent variable must be dichotomous. If the independent variables are dichotomous, then your interpretation will be more easy, more understandable for the society. If the independent variable is continuous, you can give only estimate, but you cannot compare within the categories. So increase in log odd for a unit, same interpretation is there. Dichotomous predictors, therefore, for the odd ratio associated with risk presence, we have OR is equal to e to the power beta 1. Taking natural log, I have discussed all. Thus, the estimated regression coefficient associated with 0 and 1 coded dichotomous predictor is the natural log of odds ratio associated with risk present. So these are all about the logistic regression and interpretation. I use a data which I have prepared for yourself, but the data is used. You cannot enter, but see the how I get the logistic regression and what are the output and what is the interpretation of that. Where is the entire screen? Entire screen is not there. I don't have. Okay. Okay, this is the SPSS file. This is the SPSS file. It is visible. It is visible.
Visible.
Okay. This file I have prepared. Actually, I have written a paper, and this paper is published, and this data is use NFHS3 data. This file use NFHS3 data, and in this analysis, I would like to know the various effect of various predictors on cesarean delivery, the birth by the cesarean delivery. The question is, who wants to go for the cesarean delivery, whether it is emergency or whether it is the choice. And finally, I found this is the choice. This is not emergency. And you also think this is the choice, not emergency. Every private hospital impose this cesarean delivery because this is easy than the normal delivery. They feel in the normal delivery there is a lot of complication, and in cesarean there is no. They just surgery and keep the baby. And many females like this cesarean delivery over the normal delivery. Okay, so in this, would like to know who are the groups, or who are the peoples, who are the females who like the cesarean delivery. So we make the last part cesarean section. These are the various reproductive complications or pregnancy complications: vaginal bleeding, convulsions, prolonged labor. Education, BMI. This is the categorized BMI. SLI, standard of living index, age of respondent, weight of respondents, height of respondent, and these are the various category. And these are the different category. We have categorized the age data into different dummy variables. So age 1, age 2, age 3, age 4, age 5. Age 1 is what? Less than 20. Age 2 is 20 to 24, 22 to 5, 25 to 29, 3, and like this. Education, I have categorized education. This is the continuous variable which I have categorized it into 4 categories: no education, primary, secondary, and higher education. I'd like to know what is the likelihood in higher education education people, higher educated females, whether they like cesarean delivery over the illiterate female or not. These are the basic questions in our mind when I have analyzed this data. Standard of living index is categorized into 3 categories: low SLI, moderate SLI, and high SLI. Residence, the female from the rural, come from the urban area. So there is a 2 category. So these are the variable are dichotomous. We have made the dummy variables from the continuous variable, and they are the dichotomous because we want to know the risk in each and every groups. If we use continuous data, we cannot. So place of delivery, public place, public, private, Hindu, Muslim, occupation, respondents occupation. So this is the public, okay, delivery place. Okay, antenatal visit for the pregnancy is also considered. CSD1, delivery by cesarean section for the last but one birth. Also, I would like to know whether the last one birth is cesarean baby. What is the chance of the current baby is cesarean or not? Okay, so these are the variable I have considered for the analysis. Now let us start the logistic regression. So come into the regression section. People, students, you are watching this, how to get this logistic regression, how to perform this logistic regression, because you don't have the data now. So regression, in regression, we go the binary logistic. I'd like to, this last birth is the dependent variable. There are 2 categories, only 2 categories there. Okay, these are the categories. Last birth is cesarean or not cesarean. So this is the different. Now come at the different predictors. Okay, age. There are 5 categories. There are 5 categories for the age now. We have categorized age into 5 categories. So I would like to know the risk in the younger females in comparison of older females. One category, how many category you have made? One category should be excluded. Let 5 category is there, you should exclude 1 category, and then software provide the risk for these categories. We need that excluded category is the comparison group, will become comparison group. So our finding says that this is the risk in comparison of the group which is excluded. So is education, now SLI, SLI, body mass index. CST1 T total solution. Okay. Okay. I have taken some variables from the data set: age, education of the female, age of the female, SLI, standard of living, place of residence, place of delivery, and their body mass index. Okay. Every variable is the categorical variable or dichotomous variable. No need to make this categorical from here. So be careful when you are going to use logistic regression. First, you make the categorical variable. Don't believe on this software. Software is also making categorical, but there is a problem. You cannot compare it with your desire. It is software. There is a default way. It compare only first category and last category. Here I am taking under BMI. There are three categories of BMI. Okay, here you can see body mass index of respondent for underweight, body mass index for respondent normal, and overweight. So I would like to compare with the normal category. But when you categorize the data with the software, it will compare only if comparison group is underweight or overweight. So no need to there. In save, this is the probability you can save. You want, if you want, check it. Option. In the option, you can use. You can get the classification plot, Husmer-Lomasav, goodness of fit, okay, and correlation of estimate, whatever you want. If you are not going to check this, you will not get EX beta, odds ratio. So first I had net, so only beta coefficient. So bootstrap is not required. So click OK. This slide is not visible, I think. No? Output slide is not visible. So, okay. This is visible. Output slide is visible. Let me inform whether this output slide is visible or not.
Yes, sir. Visible.
Okay. So the first table provides some summary. Okay. Not required to report. Second, this table is not required to report. Blocking variable, no need. This particular variable in equation is not required. This summary is also not required. This is also not required. This is model summary. This is required. What it tells, minus 2 log likelihood. This should be more. If it is not more, your model is not. But how much it is more, nobody knows. This is the drawback of minus 2 log likelihood. Cox-Snell square, but it provides whether our model is good or not. This is these three criterions. This is three criterion for checking your model is good or not. Husmer-Lomasav, this will provide your model is significant or not. So I think it is significant. It is good. So this is also not required. This table is not required. This is not. This table, this last table is very much required for you, and this provide all things. So okay, it gives EX beta, but not confidence interval is not given. So let us see what is the interpretation of this. Can we increase the size of this? No, I think. Okay, what is the age 2? Age 2 is what? The woman 20 to 25. And the comparison group is what? Age 1. We are comparing the likelihood in comparison of younger women. What is the chance of, in comparison of younger women, what is the chance of getting cesarean delivery for the older women? So when we compare age 2 in comparison of age 1, what is the beta coefficient? 0.601. And this is minus. This is what? This is minus. Means in this category, there is correlation is negative. means the chance is more in age 1. Age 2, the chance is less. So this beta doesn't provide a good idea. However, this exp e to the power beta provides better idea. If the chance here for age 1, the chance is what? 0. The reference category had chance always equal to 0 and odds is equal to 1 because e to the power 0 is 1. The comparison group provide the negative estimate of beta. Means in this group, the chance is less than the age 1. However, here, how much less? We can get with the e to the power beta. What is this? This value is 0.549. How much it is less than 1? In the comparison group, it is 1. For age 1, the chance is 1. And for age 2, the chance is 0.55. So 45% less chance to have cesarean delivery in comparison of women whose age is less than 20. What happened for the age 3 group? It is again less. So as age is increasing, the chance of cesarean delivery is also decreasing. This is the interpretation. As age is increasing, the chance of delivery is increasing. But for higher age group, when the woman's age is more than 35 years, again chance is increasing. Whether the estimate provide the real situation or not. After 30 or 35, the pregnancy is always risky. So there is a lot of chance that women have cesarean delivery. But in comparison of younger women, it is again less. So this finding, what this finding says that, I have said now, this is not emergency, this is choice. This is the choice. Today's cesarean delivery is choice, not emergency. Women's choose, yes, I like cesarean delivery. There are a lot of reasons. Women are not going to breastfeed their babies because of their choice, not emergency. ऐसा नहीं है कि उनके दूध नहीं होता, but they don't want to feed their babies. Now, what is the role of education? Higher women. Here, the comparison group is education group 4, higher educated group. So what happens? In the education group 1, illiterate women, there is 26% less chance. In education 2, again 32% less chance. In education 3, only 3% less chance. Means higher educated females adopt this cesarean delivery. These are the beautiful findings with the logistic regression. We cannot get this type of finding from the linear regression. SLI. The comparison group here is high SLI group. See that in the low SLI group, 38% less chance, 26% less chance in the moderate SLI group in comparison of high SLI group. Again, high SLI, those who belong from the high SLI group or richer group, they adopt the cesarean delivery. In another group, the chance of getting cesarean delivery is less. In urban, see that what happens? Urban females are more likely to have cesarean delivery in comparison of rural female, where here rural females are reference category or comparison group, and this is the risk for urban female. 47.5%, almost 48% female are more likely to have cesarean delivery in urban areas in comparison of rural females. What happens? What are the final findings? Now, PLDL. See that this is a vague estimate because there are two categories. Place of delivery. Place of delivery means public and private. Almost all in this data, the female reported place of delivery is private, not home or government hospital. So the numbers are very less in the public hospital and home. Majority of females goes to the private hospitals for delivery. That is why the chance is very high. So we cannot report. We cannot say 576 times. This indicates that the data in one category is very less. Almost all data in the one category that I have already discussed in the slide. Undernourished, under BMI, underweight females, chance is less. How much? 18% chance is less. However, overweight, the chance is what? 65% is more than the normal BMI female. So normal weight females have one, then underweight have less chance and overweight have more chance. This is more likely happens in the society. And this is the constant. We cannot report this, these things. And see that the p-value, this column provide the p-value. So which one is significant? See that all age groups are significant, up to 10%. But the educations are not significant. There is no role of education, SLI and all this. Urban females are there. Urban, this PLDL, I exclude this PLDL in the next model and see that what is the impact of this education, because all educated female goes to the private hospital. And this BMI is also significant. So now we exclude this PLDL from the model and see what happens. So exclude this. And now I also use option, this confidence interval for odds ratio. So what happens? See that. Okay. After excluding PLDL, we have another type of estimate. So you can exclude some variable and include some variables to know whether your model improves or not improves. So see here, the p-value, all variables are significant. All variables become significant. Okay. So this is the beauty of analysis. Everything will be done here, not on the software. PLDL makes the model absurd. See here, for the first model, what is the log likelihood? 1084. And here, log likelihood 1485. So this log likelihood minus log likelihood is more. So this model is more appropriate than I think. This model is more explainable, the phenomenon, the seizure and delivery phenomenon, rather than that previous model. Because in PLDL, the data is there. All females goes to the private hospital. So with this, here we can add the 95% confidence interval. Okay. So as far as reporting in the paper or in the thesis, you should also use this. So we may use this column, beta, SE. No need to report WALD and degree of freedom. P-values should be there. If want to this e to the power b, we will get. Suppose that one question come to your mind, must come to your mind. What is the 95% confidence interval for this? So just take ln of this. Okay. See here, e to the power, calculate on, open your Excel software. Dear student, open your Excel software and just compute e to the power minus 962. What happens? What will be the value? Is it 0.382 or something else? Dear student, compute it on the Excel, e to the power minus 962. And let me know what is the value. So what happens? What is the value? You are hearing me or not? Oh. Say that. What is this? E to the power minus 962. This is the value 0.382. So that okay. So that this SPSS output software is visible or not? It is visible.
Visible, sir. Visible, sir. Visible.
Okay.
Visible, sir.
Okay. So from here, these values e to the power these value provide this value. So suppose you want to know the confidence interval, 95% confidence interval for this, you can get from there. Take this just natural log of this value. This will provide 95% lower confidence interval for beta, and ln of this particular value provide the 95% confidence upper confidence interval for beta value. So as far as concerned, you want to know the beta coefficient, you can use this fashion. If you want to show e to the power beta or odds ratio, this is odds ratio. E to the power beta is what? Odds ratio. So the explanation of odds ratio or interpretation of odds ratio is more informative than the interpretation of beta. This is in the term of probability. Suppose this is 0.380. What does it mean? This is in comparison of 1. So how much it is less than from 1? This is 62.62 less. Means our interpretation is what? 62% less chance in this category. For what? For the occurrence of dependent variable. What is occurrence of dependent variable? Occurrence of cesarean delivery. So in this group, there is 62% less chance in comparison of younger women. So with this analysis, what is our main finding? Who goes for cesarean delivery? Younger woman. Who goes for cesarean delivery? Educated female. Who goes for cesarean delivery? High SLI group female, richer female. Who goes for the cesarean delivery? I cannot say the obese women, because in that case, there is a medical problem. So higher educated group, higher SLI group, and younger women goes for the cesarean delivery. Can we say this is emergency? No, this is choice. Females choose this cesarean delivery because this is easier for herself and for doctor. So this is about the all about the logistic regression. But apart from this, there is one more technique that is known as multinomial logistic regression, and the interpretation is a little bit different, and the requirement of data is a little bit different than the logistic regression. In multinomial logistic regression, the dependent variable have an ordinal variable or have more than 2 categories. Suppose I would like to know the delivery with 3 categories. Okay, vaginal delivery, cesarean. There are 2 types of cesarean also. One is full and one is partial. There is a surgery, partial surgery and full surgery. Suppose this delivery is categorized into 3 categories, then we cannot use logistic regression simultaneously. For this purpose, we have only 2 categories. If the dependent variable or response variable having more than 2 categories, we must use the multinomial logistic regression, and there some interpretation is different than this. The calculation, the interpretation is little bit different than the logistic regression. So once you are able to find out this logistic regression, you can understand the finding, you can interpret the finding of multinomial logistic regression. Okay. So if you want to ask any question, you can ask. I would like to answer. So this is one example I have taken to interpret the logistic regression outputs and what are the and what table, which table are important to show in the thesis or paper. I have already shown. So this particular 2 tables and this last table is important to show. And if you want to know some exclusion and inclusion of the variable, you can make a decision which model is better on the basis of -2 log life. Any
queries, participants?
Yeah. Any question?
Is you can unmute yourself.
Yeah, sir. Good morning, sir.
Good morning.
Can you please repeat when can we use logistic regression? When 2 dichotomous variables in independent dichotomous or nominal can be there in independent? Any?
I have already explained it.
Yeah.
The dependent variable must be dichotomous. However,
Yes.
independent variable may be dichotomous, may be continuous.
Okay. Yeah, thank you. And one more thing, sir.
Yeah.
Why you have equated p by 1 minus p to e power z? Can you please explain why?
Pardon, what is your
you
question?
have equated p by probability.
Hmm.
P by 1 minus p is equal to e power z.
Okay, you have some knowledge of statistics.
Yes.
And I can explain. P is what? P is what?
P probability.
Probability of occurrence.
Yes.
1 minus P is what? Probability of non-occurrence.
Yes.
Okay.
Yes.
The ratio of these 2 is known as what? Odds.
Okay.
What is the limit of P? 0 and 1. Between 0 and 1, P doesn't more than 1, does not less than 0. Okay.
Okay.
And 1 minus P again lies between 0 and 1.
Yes.
The ratio of P upon 1 minus P lies between 0 to infinity.
Yes.
Is it right? That
Yes.
is why I have used this transformation.
Okay.
Any other?
Yeah. Why z, sir? E to the power of z.
Z is the combination of right side function.
Okay.
Beta 0 plus beta 1x1 plus beta 2x1.
Okay, sir. Thank you, sir.
I'd like to answer one person's answer. Yesterday's questions. One person asked a question: why capital R is positive? Who is the person? I have one very good explanation for this. Actually, dear, R, multiple correlation, also can be equal to explained variable divided by total variability. Okay, this is the ratio of what? Explained variable and total variability. So variability is always positive, and both are in numerator and denominator. So the ratio of positive value is also positive. That is why this multiple regression never be negative. Is it clear?
Yes,
So
sir.
when you want to answer, you you can give the answer. You can give this answer. This answer is, I think, more good than the previous answer I have given yesterday. Any other question?
So some questions are coming in chat box, if you can see.
Sir, please explain e to the power beta column from Manna. E to the power beta is odds ratio. Actually, beta is the coefficient similar like to the simple regression. And e to the power beta is odds ratio. The interpretation of odds ratio is like the probability, because when beta is equal to 0, e to the power 0 becomes 1. And this is the risk of reference category. And you will get e to the power beta for the different category either less than 1 or more than 1. So that value which is less than 1 or more than 1 is very easy to explain in comparison of 1. When it is more than 1, suppose it is 1.7, then we can say 70% more likely to occur in this particular category, the response variable. If the value of e to the power beta is 0.2, then it is 80% less chance, because it is less than 0.8, less than 1. So it is very easy to compare, explain with the help of this e to the power beta rather than beta. Beta provides how much increase or decrease when independent variable increase by unity. Is it clear? Is it clear? Okay, thank you. Please repeat the interpretation. I think I have already done. The square of b. You cannot understand what is b. The square of b. Can ask this Tapas Kumar Sahu. What do you want? Tapas, what do you want to say? The square of b. Not here. I think, Jyoti, there is no question.
Yes, sir.
Some links are
Sir,
given there.
actually, that one you are asking for calculation. At that time, I am.
Oh, not I square, e to the power beta. E to the, here beta is given, and this e to the power beta is given. Means e to the power this value provide this. Your question should be, what is the 95% confidence interval for beta? That is why I have said calculate with these values. Take natural log of this value. This will provide 95% lower confidence interval for beta. And ln of this particular value provide upper 95% upper confidence interval for beta. It is not given in the table. This 95% confidence interval given for e to the power beta. Na? People may want the 95% confidence interval for this beta also. Okay. Any other?
So like sometimes we often find the b value either positive or negative. Like what is the
Yes.
influence of such b value if it is positive or if it is negative?
Yes. When it is negative, the correlation between these variables are negative. When it is positive, correlation value is positive. When the value is positive, e to the power beta is more than 1. When the value of beta is less than 1 or negative, its e to the power beta is less than 1.
So while interpreting, sir, we have to check it so that
Yes.
proper
The interpretation of e to the power beta is more informative rather than this. This is same as the simple regression, but this is in terms of the probability. The interpretation of this particular e to the power beta in terms of probability. So it is easy now. How much chance is more in a particular category rather than in reference category. So it is more informative, and people or policymaker wants to know whether in urban area the likelihood more or rural area is more, so that they can make the program, they can launch the program in particular area. That is why this logistic regression today is very important and technique to analyze the data set. Everybody want to know how much chance. They want some interpretation in terms of chance, and this logistic regression provide this type of estimate.
Thank you, sir.
I think this is too much complicated for non-statistician. For statistician, they can understand easily. And in this program, many people from the commerce and non-statistical background. So that I think they are, I don't know how much they understand this talk, how much getting, but my, I have tried to explain better and better so that they can use. But when they use this for the analysis, they can easily understand and easily interpret the results.
Yes, sir. So, like, is there any, if possible, can you show one or two examples more so that you can understand it in a very good manner, if possible?
What?
If you can put forward some more examples as regards to logistic regression.
More example, I have no data from the business side or any sociological, because my area of interest is mathematical demography, and I have this data for written a paper. So I have this and I search that data. So I'll get this. If you have any data, then you can share and I can explain.
Participants, if you have any data regarding logistic regression, if you have any data, participants, you can share with sir, and sir can help you in this particular analysis. If you have
the way how to analyze, I have showed. First students prepare the data. It is very important for the logistic regression. If you depend on the software, you will not get a good findings. First, prepare the data. What are the response variable and what are the independent variable, predictor variables? You must prepare all the predictor variable in the categorical form, in the dichotomous form. Then you will get the finding like this. Otherwise, no. The SLI is given in NFHS data, but I have categorized it into the 3 categories. Age is given, respondent's age is given. I have categorized it into different category. Then I'll get this estimate and I can interpret the result as in this group, the chance is higher. In this group, if chance is lower. Suppose I am taking this age as a continuous. You will have a estimate, e to the power beta, suppose 1.3. So what is the interpretation? If age is increasing, risk is increasing. This type of information can have. But this is not useful. But here we have the different estimate for the different groups. When we compare this group with this group, I have this risk. So it is better when you are going to analyze the logistic your data with logistic regression, you must prepare all the variables considered, whether it is dependent or independent in the terms of dummy variable or dichotomous variable. So in one lecture of 1 hour and 2 hours, you will not get all the things. Do yourself, and when you face some problem, ask some statistician wherever you are there in university or college. Ask the question, yes, I am facing some problem here. They can explain. It cannot be summarized in 1 or 2 lectures. The way how to get logistic regression, I have showed. Whatever the data is there, the output is different, but the way of finding this logistic regression is same. If you have any other questions, then I can give the answer. And one more thing, suppose you want, suppose we have 2x2 table, 2x2 table. Then you'll get a odds ratio. So let I am showing. slides. Okay. I want it. Okay. This is the data. 2x2 data. You can get the value AD by BC. Suppose it is A, it is B, it is C, it is D. So odds ratio is AD by BC. AD by BC. So this will provide this same thing. Is it clear? We have taken the ratio of this value upon this value. Suppose I would like to compute with AD by BC. This is A, this is B, this is C, this is D. AD means 21 into 51 divided by 6 into 22. What is the value? The value is same. And what is the ratio of this? 21 upon 6 divided by 22 upon 51 is equal to 21 into 51 divided by 6 into 20. So AD by BC is the primary rule to get the result. Actually, software did this. So when you have 2x2 table, use this particular formula. If you don't have, use software, directly software, whether it is SPSS, Stata, and System, everywhere the same way to get the logistic regression.
Sir, sometimes in substitute to logistic regression, we often use probit regression. So, like, what is the basic difference between both the?
Probit is different. For non-Stetson, it is very difficult to understand. Where we use probability terms, but the normality assumption is prevailing there. So probit is less popular than the logistic regression. Logistic is more popular than the probit. And the interpretation of probit is little bit complex than the logistic regression. There are so many regression, probit, logistic, multinomial logistic, multivariate, so many. But this logistic is very useful and very informative technique. That is why it is used more.
So I think there is no more questions, sir. So
one person, Dr. V. and Purna, says, sir, please share the PPT and the output file. Oh, I can share. I have shown now.
Yeah. You can send it to me, sir. I will send it to them.
Okay.
I request Miloji to please unmute yourself and give the vote of thanks to Professor Brijesh, sir.
Hello, am I audible? Hello?
Yes, you are audible.
Okay, good morning, everyone. I am Milo Mamung, a research scholar from Rajiv Gandhi University, Arunachal Pradesh. At the very outset, my heartfelt thanks goes to the Department of Business Administration of Assam University, Silchar, for organizing this program and giving me opportunity to address the vote of thanks for this session. I am honored and privileged to express my gratitude and thanks to today's resource person, Sir Professor Brijesh P. Singh, for sharing your valuable knowledge, information, and enlightening insight upon the topic, logistic regression, analysis, and interpretation. Dear Professor Brijesh Sir, we believe and hoping that your information and knowledge shared with us today will be helpful and useful for each one of us in our academic journey. Once again, thank you so much, sir. Thank you, sir.
Thank you. Thank you. Thank you, dear participants.
My sincere thanks to all the program coordinators, technical coordinators, and the participants of this session for your support, cooperation, and dedication. And thanking each one of you for making this session successful and fruitful. Thank you so much. Take care, everyone. Stay safe, stay blessed. Jai Hind. Thank you, everyone.
Thank you.
Thank you,
Thank you,
Devjyoti.
Thank you, sir.
I have saved for 30 minutes.
No,
because this logistic regression cannot take half an hour.
Yes, sir. Okay, sir.
The theory is not much more, na? So we cannot take more than half an hour.
Okay, sir. No issues. Thank you, sir.
Thank you. I'll send your 2 documents after signing it.
Okay, sir. Thank you.
Okay. Thank you. Thank you, Devjyoti. for giving me chance to share some knowledge
Sure, sir.
in your
I'm
audience.
also looking for future opportunities, sir. In similar.
Give my compliment to Dibjyoti.
Yeah, surely, sir.
Okay, bye.
Thank you, sir. So participants, we are meeting again at 12:15 for the next session. So for that timing, let us have a break.